human blood groups, every individual has a unique profile of proteins on the cell membranes, especially of red blood cells. These are called antigens, autoantigens. They are antigenic for other people. They are not antigenic to you. It's the way that your body tells what belongs there and what doesn't belong there. And these are glycoproteins that sit on the outside of the membrane and are really kind of flags or markers. A and B and RH are the common ones. They're the ones that we test for. They're the ones that cause aggressive reactions. But there's actually 33 different types. This says 30, but there's 33 different systems. There's systems, so there's the ABO system and the RH system, but there's also MSN or MNS, Kell, Lewis, P, Lutheran, Duffy, Kidd, Diego, all kinds of different systems are identified, and every individual has a unique blend of these antigens. Like I said, the ABO and the RH are vigorous and strong. The weaker agglutinogens really are the other ones. So agglutinogen means it generates it causes agglution of cells, which is really meaning sticking together. So the best known and probably the most important are the ABO groups. Now, there are two types of antigen in this blood group, in this blood system. One is A, and the other one is B. And if you have the A antigen and you don't have the B antigen, you make anti-B antibodies. If you have the B antigen and don't have the A, you make anti-A antibodies. You don't make antibodies against the type that you have. You make against the type that you don't have. So this happens automatically when you're very young. You make the antibodies against the ones that you don't have. When we look at it, the people that have type A antigens here make anti-Bs. The people that have only B antigens make anti-As. The people that have both A's and B's don't make any antigens. And then this is type O, which is really a 0, which means they don't have either type A or type B. So they make both anti-A and anti-B. So type AB blood has no antigen, or it has both antigens, no antibodies. Type B blood has B antigens, anti-A antibodies. Type A has anti-B antibodies, A antigens, and O has 0 antigens, both antibodies. So when you start to pull this together, this means that when you transfuse, if you have type A blood, if you are given type A blood, there are no anti-A's to attack it. You will be fine. If you're given type O blood, there is no B antibody on that O blood for your anti-B's to attack. So you can accept that as well. But if you're given type B blood, your anti-Bs will attack the B antigens on that donated blood. If you're given AB blood, your anti-B antibodies will attack the B antigens on the donated blood. So type A can take from A's or O's. Type Bs similarly can take from B's or O's. Type AB, because it has no antibodies, can take from any of the others because there's no antibodies that will attack the antigen. So if it gets B, it's fine. If it gets A, it's fine. If it gets O, it's fine. Type O, however, has anti-A's and anti-B's. So if it gets AB, it attacks it very vigorously because it attacks both the A's and the B's. If it gets B type blood, the anti-B's attack the new blood. If it gets type A blood, the anti-A's attack the new blood. The only blood that a type O person can get is other type O's. So O can give to everybody, AB can get from everybody, and A's and B's can get from their own kind and O. Now, there's another set of blood groups called Rh, and they were originally found in rhesus monkeys, and that's why it's Rh. There's a whole bunch of different types of agglutinogens that fall under this Rh category, but we will look mostly at just the one, and it's the Rh. It happens to be type D. It doesn't matter. If you are Rh positive, that means that you have this antigen on your cells. If you are Rh positive, you don't make anti-Rh antibodies because you would attack yourself. So you never make the anti-Rh antibodies. If you are Rh negative, that means you do not have the antigen, and you will make the anti-Rh antibody, but only if you are exposed to Rh positive blood at some point. So if somebody is Rh negative and they get a transfusion of Rh positive blood, it will work the first time. But then they will develop antibodies against that Rh positive blood, and the second exposure to Rh positive blood, will mean that they'll have a transfusion reaction. They will have agglutination and the transfusion won't work. This isn't a big deal for people that have never had a blood transfusion. But it is a big deal when it comes to pregnancy. And it's a big deal because if a mother is Rh negative and the baby that she's carrying is Rh positive, the first pregnancy will work. The blood of the fetus and the blood of the mother don't mix until the placenta starts getting disrupted. So usually they go full term. When they go full term, then and she goes into labor, and the bloods actually mix, the Rh negative mother will make anti-Rh antibodies to attack the baby's blood, but usually in the first pregnancy, that doesn't matter. The baby's born before the mother can make enough antibodies to affect the baby. However, in subsequent pregnancies, the problem is the anti-Rh antibodies can cross the placenta, and it actually destroys the baby's red blood cells because the anti-RH will attack the baby's Rh positive red blood cells and will result in stillbirth or or spontaneous abortion. Really, it's called erythroblastosis fetalis, and it's a big problem. Now, it's interesting. An Rh positive mother can have an Rh negative baby, and it's fine because the baby's not big enough and hasn't actually developed enough an immune system to actually attack the mother. The only time this matters if the mother is negative and the baby is positive. And there was a point where back in the 30s, 40s, and 50s that people used to have to get blood tests before they could get married because of this problem. We have since found ways of suppressing the immune system and making it not happen when people take shots for it. But there was a point where I think they would try to enact laws that said Rh negative women couldn't marry anybody but an Rh negative man, just for this very reason. I don't think it went very far, but that was what they were thinking at the time. And Lord knows you can't possibly have a baby with somebody that you're not married to. It just apparently doesn't work that way. So what happens, and they used to call it blue babies because the babies would be born with not enough red blood cells to actually, and so they'd be born hypoxic, and so they would have a blue tinge to them. So they now can give transfusions even before birth. They do transfusions at birth. A lot of times these can go full term, and there's not very much, not a huge reaction until labor, and then that's when the bloods mix and it becomes really bad. So they give people RhoGAM, and it stops mothers from becoming sensitized. So what happens? What's this transfusion reaction I've talked about here? What happens is if the blood is mismatched and it's infused, the donor's cells are attacked by the recipient's stuff, right? It's not that there's usually enough blood from the donor to attack the recipient's blood. It's overwhelmed the other way because you're given 1 unit of blood and mixing it with the 12 of the, it doesn't work that much. But what happens is that the small amount of donor blood, the red blood cells actually stick together. The antibodies, the anti-A's or the anti-B's, cause agglutination, which is the sticking together, the clumping up of the red blood cells. And what ends up happening is they start to clog the capillaries and the small blood vessels and that kind of thing. They will rupture, and the hemoglobin will end up in the bloodstream. So it means that you will have fewer red blood cells, so you got diminished oxygen supply. You'll end up with hemoglobin in your kidneys, and that can cause renal failure. It'll screw up osmosis at capillaries. It can be really nasty and very painful, and one would presume that the only reason you get a transfusion is because of blood loss. So this would add insult to injury. It would make things far worse. So what we do is we type blood. We try and figure what type of blood people have so that we know. And so what we do is we take drops of blood and we put anti-A, anti-B, and anti-RH in the 3 different drops of blood, and we see what happens. If with using the anti-A serum, we have agglutination in the in A's, or we have agglutination, that means there is an A antigen there. If we use the anti-B serum, and we get agglutination, there's a B antigen there. If we use the anti-RH and we get agglutination, then that means there is an RH. So an AB positive blood type would have agglutination in all 3 drops. An O negative would have no agglutination in any of the 3 drops. So the reaction, and so this is the chart. So if you have A and B and the RH agglutinate, then you are AB positive. If you have B, you would have a reaction with the anti-B but not the anti-A, and if you had a reaction with the RH, you would be B positive, which happens to be my blood type. Anti-A has a reaction, anti-B doesn't, RH doesn't, you would be A negative, etc. And the drops end up actually looking like this. You can see that so an AB person has agglutination in both the anti-A and the anti-B drops. The type A person has agglutination, the clumping together of red blood cells in the anti-A, but not the anti-B. B has the agglutination in the anti-B. O has no agglutination in either one.